Okay, I have more lecture and I have to do 2 more demos. One is remove of 6mm instrument. The other one is non-visible instrument beyond the curvature. So 2 more demos left. So when the broken instrument is longer than 4.5 millimeters, as you can see, or the instrument didn't come out with ultrasonics for 10 seconds, then it's time to try another technique. That is the loop or rotary file, XP shaper, or multisynthetic phase rotary file. So this is the loop, the new loop. The new loop is different from the previous loop in that we have 2 different sizes. One is small, the black one. The other one, the brown one, is a bigger size. So bigger size is always more resistant to fracture. But I always want to use small size because you don't need bigger space. You just need small space. So let me show you the difference. If it's broken, you don't have to buy the whole thing. You just have to replace the broken loop with a new one. So this is how you remove the broken loop. Remove the cap like this. Take it out. And remove the metal cover like this. And replace it with a new one. And place the new one exactly in the same place. You see the slot? Put it in the same place. You see the rectangular metal going into the rectangular space. This one here. You see the rectangular space. This rectangular metal prevents the loop from rotating. And place the metal cover back in the same place. You see the circular space and rectangular space. Put it exactly in the same place. Make sure there is no gap between the 2 parts. If there's no gap, return the cap and turn it clockwise to tighten it. This is how you replace the broken loop with a new one. So as you can see, this is the new loop. The new loop is much smaller than the previous loop. The tip size is 0.25 millimeters. The biggest size is 0.5. And you need only 0.5 space to grab the broken instrument. There are 2 things that you have to do before you use the loop. First, you need to adjust the loop size and bend it to 45 degrees to facilitate the placement of the loop. So if you want the loop to be smaller, use the small part of the DG16. You can use any endodontic explorer. If you want the loop to be bigger, use the coronal part of the DG16. So you can just put it in the loop like this. You put it in the loop and close the loop to adjust the loop size to the broken instrument and bend it to 45 degrees. This is how you use the loop. So if you bend it to 90 degrees, you need more space. But if you bend it to 45 degrees, you don't need big space. And the loop will be pushed back to 90 degrees on the broken instrument. And here's the loop. Because after the preparation is completed, the broken instrument is dancing. So all you have to do is just place the loop and tighten it and take it out. If you feel resistance, try several directions, like 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock. One of the directions will allow you to remove the broken instrument. Don't use your force. Just take it out gently. For example, let me show you this case. The broken instrument measured 9 millimeters. And the curvature was not big, 16 degrees. So you need to create a space about 3 millimeters because the curvature is less than 30 degrees. So let me show you how I remove this instrument. First, the first step is always to make a treatment plan based on the diagnosis. Measure the instrument, measure the curvature located in a wall. First, you need to enlarge the canal in a funnel shape, like this. Irrigate the canal with EDTA. Then brush against the outer wall to make a funnel shape. Making a funnel shape is the most important. Don't go to the next step without making a funnel shape. So this is TFRK katana B. Always direct the flat surface towards the broken instrument. So I'm extending the space with a katana tip on the inner wall. So this is the broken instrument. EDTA injected into the canal, remove debris. And in this case, I'm using rotary file to extend the space. So I'm using the T mode, starting with a 90-degree watch winding. Then I'm extending the space with a reciprocating motion, 380 degrees clockwise and 50 degrees counterclockwise. This is much faster than using ultrasonics. This is S2. I do the same. Because broken instrument is extruded into the periapical tissue, that's why you hear the sound coming from the apex locator, telling me you are reaching the apex. But I know the length. I measure the length from the orifice to the midpoint of the broken instrument. And this is F1. I go from S1 to F3. And I'm using the reciprocating motion, 380 degrees clockwise, 50 degrees counterclockwise. So I measure the length, so I don't depend on the apex locator. Here comes F2. I do the same, 90-degree watch winding, followed by reciprocating motion, 380 degrees clockwise, 50 degrees counterclockwise. Now I have reached the midpoint. This is much faster compared to the ultrasonic extension. So look, instrument is dancing, right? It's dancing. So after using F2, F3, usually instrument is dancing. Then I'm going to use the Micro Explorer, Micro Trifine bar, because if you want to use a loop, you need a space around the broken instrument. But I didn't see the space on the outer wall. So I decided to use the Micro Trifine bar. I'm just removing debris from the Micro Trifine bar using the Micro Explorer. So EDTA inside, I'm spinning the Micro Trifine bar counterclockwise to remove overhang from the outer wall. Then irrigate the canal, again EDTA, sodium hypochlorite, and hydrogen peroxide. Now I see the space around the broken instrument. So I'm ready to use the loop. The broken instrument is already dancing. Here comes the loop. I'm placing the loop over the broken instrument and tightening the loop around the broken instrument. Then, gently, I'm taking the instrument out. So it came out like this. So this is the instrument that I removed from the medial root. And this is MTA obturations. And this is 3 months post-op showing nice periapical healing compared to the preoperative lesions. So here you see the broken instrument placed into the inferior alveolar nerve. So you have to be minimally invasive, particularly in this kind of case. So what I did was the same. I wanted to make the broken instrument rotate counterclockwise. If you want to make the broken instrument rotate counterclockwise, you need to spin the rotary file next to the broken instrument. If you spin the rotary file clockwise, you can make the broken instrument rotate counterclockwise. This is my treatment plan. So I wanted to use XP Endo shaper. Then I wanted to make the broken instrument rotate counterclockwise. So it will go up if the broken instrument rotates counterclockwise. Then you can loosen the broken instrument. So let me show you how I removed this instrument. So this is the same. You need to make a treatment plan. So this is TFRKS. I just wanted to remove the inner wall because it was touching the broken instrument. Then I'm going to introduce the XP Endo shaper. So I have the space. I'm still removing the inner wall. You can see it flexing. It's not dancing. So I'm going to use the XP Endo shaper to make the broken instrument rotate counterclockwise. I'm preparing the XP Endo shaper. I'm putting the XP Endo shaper into the handpiece. So here comes Before that, I need to use silicone oil because I'm going to use higher speed, 2,500 RPM. But unfortunately, the XP Endo shaper will break. But I was successful in making the broken instrument rotate counterclockwise. So it's already dancing. However, I needed to remove the fractured XP Endo shaper. But usually, whenever the XP Endo shaper broke, it's easy to remove. You see the spaces around the XP Endo shaper. You just have to push it from the inner wall. I'm just pushing the broken instrument from the inner wall. I mean the broken XP Endo shaper. Now it came out immediately. It's always easy to remove a broken XP Endo shaper. So here, this is the broken XP Endo shaper. It came out. Here. This one. Then it's already dancing. So first I want to remove debris. I use ultrasonics to agitate EDTA. to remove debris. Then I use sodium hypochlorite to remove oil because I use silicone oil. Whenever you want to remove oil, you need to use sodium hypochlorite. Then I use hydrogen peroxide after I use sodium hypochlorite. So you can make lots of bubbles. Bubbles usually help remove debris. So I'm getting ready for the use of the loop. Make sure there's no gap between the two methods. Then I'm returning the cap, tightening it. Then I'm adjusting the loop size, bend it to 45 degrees to facilitate the placement of the loop. So I'm going to place the loop over the broken instrument and tightening it, and slowly I'm taking the instrument out. And it came out. So it's easy, right? Nothing difficult, right? You can do the same. Everybody here can do the same if you do exactly what I did. Nothing difficult. You may not break the file. Here, you see, I stayed minimally invasive. Look at the feelings. I didn't sacrifice lots of denting. And this is 3 months post-op showing nice periapical healing. So sometimes you don't see the instrument dancing. There are 3 major factors why the broken instrument is not dancing. If you look at the technical factors, you didn't make a funnel shape. This is the most important. If you don't make a funnel shape, it's very difficult to make the broken instrument dance. If you activate ultrasonics from the outer wall, it's difficult to make the broken instrument dance. And if you activate ultrasonics on the top of the broken instrument, you will end up pushing the broken instrument into the apical direction. If you haven't completed 180-degree semicircular space, it won't dance. If you use big size ultrasonic tape, it won't dance. If you use the ultrasonic tape with a big taper, it's very difficult to make it dance. If you didn't extend the space beyond the midpoint, when the curvature is more than 30 degrees, you won't make it dance. As I told you, if you look at the time factors, the larger the instrument, the more preparation time. The longer the instrument, more preparation time. If you are dealing with an austenitic instrument, it takes more time because it wants to straighten. If you have a broken instrument around severe curvature, the more time. If you don't use silicone oil in preparation, especially when the curvature is more than 30 degrees, you need more time. If you don't use a microscope, maybe you will not be able to remove the broken instrument. And there are 9 techniques that I developed to remove the broken instrument. Preparation, you can use ultrasonics. When you do the removal attempts, you can use ultrasonics. And also, you can prepare the canal with ultrasonics, followed by multensthetic phase nickel titanium instrument using the T mode to extend the space. And you can use ultrasonics in the removal attempts. And preparation can be the same, starting with ultrasonics, followed by multensthetic phase nickel titanium instrument to extend the space. When it comes to the removal attempts, you can use piezo flow, you can use XP endo finisher, you can use XP endo shaper, you can use rotary files, you can use XP endo finisher, you can use a combination of XP endo finisher, ultrasonics, and piezo flow. And you can, if the broken instrument is outside the canal, you can simply use piezo flow or finisher or ultrasonics. You can use a loop, even the broken instrument is not visible, you can get it to go to more chrono level where you can see it. Then you can use the loop to get the instrument out. So I will show you another technique. So you can use XP shaper or finisher to remove the broken instrument longer than 4.5 millimeters. So this is the XP endo shaper. The taper of the XP endo shaper is 1%. It has a snake-like shape. So that's why if you spin it, you can make the broken instrument rotate counterclockwise. If the broken instrument is already dancing, you can try XP endo finisher, because XP endo finisher, you cannot cut denting. But with the XP endo shaper, you cut denting. So if you want to be minimally invasive, you can always use XP endo finisher. I'm developing a new instrument from FKG to remove the broken instrument. It's very similar to XP endo finisher, but it's more efficient. So if you see the broken instrument leaning against the outer wall, you cannot place the loop over the broken instrument. If you are in this situation, and when the curvature is less than 30 degrees, you can try the XP endo shaper. This is a cross-section of the XP endo shaper. If it's spinning clockwise, you can make the broken instrument rotate counterclockwise. If the broken instrument is rotating counterclockwise, it will go up in a coronal direction. If it goes up, the instrument is already dancing. Then you can make a removal attempt by using XP endo shaper, making the broken instrument come out. So you can use higher speed to prevent instrument fracture or maybe to prevent the deformation of the instrument. You know, the larger the diameter of the instrument, use the lower the cyclic fatigue. For example, if you are using, the instrument smaller than number 30 and the curvature less than 30, you need to use higher speed because you are using small size instrument. If you slow down, you will have lots of torsional fatigue. So to reduce the torsional fatigue, you need higher speed. You need to spin it at higher speed, like a 2,000, 3,000 RPM. If you slow down, you have lots of torsional fatigue, especially when the curvature is more than 30 degrees. If you are using an instrument larger than number 30, and if you are using higher speed around the curve more than 30 degrees, you could have lots of cyclic fatigue and you will fracture the instrument. In that case, you need to slow down. If you slow down, you can reduce the cyclic fatigue. This is how you choose the speed. So every case is different. So I always keep changing the speed depending on the curvature, depending on the size of the instrument I use. For example, in this situation, you have a broken instrument almost in a canal less than 30 degrees. So in this case, you can use higher speed. So let me show you how you can remove this instrument. So let me show you the preparation technique. Again, you have to start with number 3 GG bar. Once you touch the broken instrument, start brushing against outer wall. So actually I'm brushing against outer wall. Yeah, I'm brushing against outer wall. Then I'm using the katana tip. I look for the sticky feeling. Whenever you feel sticky, activate ultrasonics only on withdrawal. Of course, you can keep using this technique until you extend the space beyond the midpoint. But it takes lots of time. So in this kind of case, you could use multi-synthetic phase nickel titanium instrument. But you need to create space for the nickel titanium instrument. So I created the space about 1/3 of the broken file length. I think this is enough. This is about 1/3 of the broken file length. Then you can use multi-synthetic phase nickel titanium instrument. First, you need to inject oil, silicon oil. This is silicon oil. Then take out multi-synthetic phase instrument. This is S1. I'm using 90-degree watch winding. After passing the midpoint, I'm using now reciprocating motion, 380 degrees clockwise, 50 degrees counterclockwise. Here comes S2, 90-degree watch winding. After passing the midpoint, I'm using reciprocating motion. You don't have to be on the inner wall. You can go around the broken instrument with a rotary file because you want to just make the broken instrument rotate counterclockwise. Simply, I'm just extending the space beyond the midpoint. Don't completely bypass the broken instrument. If you bypass the broken instrument, you will open the door to the apical direction. So it means you can end up pushing the broken instrument into the apical direction, which is not good. So here comes F1. I will start using 90-degree watch winding, like this. After passing the midpoint, I want to use reciprocating motion with a small up and down motion, like this. You can always go back whenever you feel resistance. So this is again reciprocating motion. Then here comes F2. But before that, always irrigate the canal each time. This is silicon oil. I irrigate the canal with silicon oil. Sometimes if you see lots of debris, I want to use EDTA. But when you use file, you need silicon oil because you are creating friction between the two metals, two metal instruments. So I don't feel sticky anymore. It means whenever I lose a sticky feeling, the instrument should be dancing already. Then you can make a removal attempt. In this case, the curvature is less than 30 degrees. So I want to use XP Endo shaper spinning at 2,500 RPM. Now instrument is coming out. So this way, you can remove the broken instrument. So here, you see the broken instrument. If you do the same, you can remove the broken instrument. So let me skip the preparation. This is the same. So after that, I'm going to press the XP Endo shaper. This is oil, soybean oil. Up and down, up and down. Then instrument came out like this. Always use oil, soybean oil. But in preparation, use silicon oil. It's much, much better. In this case, look, you see the perforation coronal to the broken instrument. Big perforation. But it doesn't matter because the preparation is the same. Create a space on the inner wall. And you can keep using ultrasonics to extend the space beyond the midpoint. But you can also use rotary file to extend the space. If you use a rotary file, you don't have to stay on the inner wall. You can go around the broken instrument. So here, again, create a space with ultrasonic tape. The katana tape or straight tape, it doesn't matter. Then you will use multi-synthetic phased instrument, use the T mode, starting with 90-degree watch winding at 100 RPM, followed by the reciprocating motion, 380 degrees clockwise, 50 degrees counterclockwise at 150 RPM. And when the curvature is more than 30 degrees, you need to use rotary file. Or if the broken instrument is completely dancing, you can use finisher, XP and the finisher. For example, if it's already dancing, look, it's around the second curve. This is a broken instrument. First, enlarge the canal in a funnel shape, like this. Then, after making a funnel shape, you will use multi-synthetic phase instrument. I'm using the T mode. Always start with 90-degree watch winding until you get to the midpoint. After the midpoint, you can use reciprocating motion. So here comes the reciprocating motion. And you will go to the next bigger instrument, do the same. And this is F3. Do the same. After passing the midpoint, use the reciprocating motion. Always measure the length, because this instrument is beyond apical foramen. So you cannot trust the apex locator. And here is a 6002. No broken instrument can survive 6002 multi-synthetic phased instrument. After using 6002 multi-synthetic nickel titanium instrument, the broken instrument is already dancing. No instrument can survive 6002. It's a big instrument. So now it's dancing. Broken instrument is dancing, as you can see. So I'm going to make a removal attempt using XP finisher. If the broken instrument is dancing, you can take the instrument out. It's here, coming out, came out. Sorry. And when the broken instrument is around the curve more than 30 degrees and longer than 4.5 millimeters, instead of using XP and shaper, you need to use multi-synthetic rotary file. One size or two sizes smaller than the final preparation size. So preparation is almost the same. Make a funnel shape using number 3 GG bar. Create a space on the inner wall with the ultrasonic tape, maybe katana tape. Then you will use multi-synthetic phase nickel titanium instrument. Where is my cursor? Here. So use the multi-synthetic phase instrument starting with 1504, 2504, maybe 3504. Then you will pick up the instrument one size smaller than the last file you use, or two sizes, because you need a space to let the broken instrument rotate counterclockwise. You don't need bigger space, but you need small space to let the broken instrument rotate counterclockwise. So here, let me show you. This is almost the same. Maybe let me skip this part, because this is the same. For example, here, not this one, sorry. For example, here, let me go back. You have a broken instrument around the curve. You do the same. Not sorry. Not this one, sorry, I'm sorry. This one, sorry. If you have a broken instrument beyond the curve, preparation is the same. Enlarge the canal in a funnel shape. you have to brush against the outer wall. So you need to keep brushing against the outer wall. Then enlarge the curved canal. I'm using Sonix because I want to reduce the cyclic fatigue and torsional fatigue. After passing the midpoint, I want to use reciprocating motion. By the way, broken instrument is here beyond the midpoint. I'm sorry, beyond the curvature. I'm activating Sonix to reduce cyclic fatigue. Now I'm using reciprocating motion, 380 degrees clockwise and 50 degrees counterclockwise. Here comes S2. I am doing the same 90-degree watch winding with Sonix with a small up and down motion. I'm approaching the broken instrument. Don't consider this case difficult. Consider every case easy. This may look difficult for you, but this is easy. Just follow the protocol. Everybody can do the same if you follow the same protocol. Here comes F1. Do the same. Always start with 90-degree watch winding with a small up and down motion. After passing the midpoint, use reciprocating motion with Sonix, like this. Then here comes F2. This is F2. 90-degree watch winding with Sonix with a small up and down motion. After passing the midpoint, then I want to use reciprocating motion. So I'm using the reciprocating motion. You need to measure the length to the midpoint of the broken instrument. Do not completely bypass the broken instrument. You will end up pushing the broken instrument into the epical direction. And here comes F2. Do the same. As I told you, no instrument can survive 6002 multi-synthetic phase instrument. After using 6002, every instrument is already dancing. So broken instrument stays in the same place. This is 5004. 90-degree watch winding with Sonix and reciprocating motion. As you can see, the broken instrument is already dancing. And this is F2. I'm going to make a removal attempt. I'm now rotating the file clockwise, not reciprocating motion. Because if you rotate the file clockwise, you can make the broken instrument rotate counterclockwise. If the broken instrument is rotating counterclockwise, it will come up into the coronal direction. Sometimes you need to use smaller file because you don't have space for the broken instrument to come out. So in that case, you need to use smaller file. It's already dancing, as you can see. So I'm going to use a smaller file. This is 2004. I'm rotating the file clockwise at 100 RPM with a small up and down motion. Because the broken instrument is rotating counterclockwise, it's climbing up the wall into the coronal direction. Then it came out. So this way, you can remove the broken instrument. Always rotate the file clockwise to make the broken instrument rotate counterclockwise. But you have to slow down, especially around the sphere curve. The more curvature, the slower the speed. This is how you use the bar. Use the speed. Okay, let me do the demo for the 6mm instrument.